Did you know that Kotlin can smartcast a variable in response to calling your own functions? Today we're going to use contracts to make that happen. Here I've got a simple model for a user. With this sealed class, every user is one of two kinds. It's either an anonymous user or it's an authenticated user. Notice that the isAuthenticated function is declared on the user class, so it's inherited by both subclasses. But each subclass also has a function that's unique to it. The prompt to sign in function is only available on the anonymous class, and the greet function is only available on the authenticated class. Now let's say we've got some kind of an app, and when the screen loads, we want to do one of two things. First, if the user is authenticated, then we want to greet that user by name, like welcome Dave.leads. If the user is anonymous, then we want to prompt that user to sign in. A simple approach might look like this. We can check to see if the specific type of user is authenticated. And when we do that, Kotlin does a smartcast. This pink color that you see here in my IDE means that there's a smartcast. And if we put the mouse cursor over this, IntelliJ tells us exactly what's happening. So inside this true branch, the user has been automatically cast to the authenticated type. On the other hand, down here in the else block, we don't have pink, we have red, which means that there's a compiler error. And that's because the prompt to sign in function only exists on the anonymous user class. But Kotlin didn't do a smartcast for the user inside this else block. So its type is still the more abstract user type. To remedy this, one option would be to add an if to our else like this. Now, of course, if you find yourself doing this, it's a good idea to switch to a when construct instead, which is a lot more idiomatic for Kotlin. When we use a when combined with our sealed class, the Kotlin compiler knows that there are only two options, so it ensures that we cover exactly those two cases. And as you can see from the pink here, it does a smartcast in each one of those cases. So when adding these type checks explicitly, the compiler has the knowledge that it needs in order to know how to cast the user parameter. With this approach, everywhere that we want to get a smartcast, we have to explicitly call out the authenticated and anonymous types. And that might be exactly what you want. But instead, what if we could move those type checks inside a function? So in other words, what if we could update onScreenLoaded here so that it looks something like this? Here we could call this function isAuthenticated, and if it's true, then maybe Kotlin could smartcast user here for us to the authenticated type. And otherwise, maybe it could smartcast the user object to anonymous on the else side. And in fact, Kotlin contracts will allow us to achieve this. The way that we've written this code, when the isAuthenticated function returns true, then the user object must have a type of authenticated. And if it returns false, then it must have a type of anonymous. You and I as developers know this because we wrote the code, right? But the compiler doesn't understand that. With contracts though, we can communicate this kind of information from the developer to the compiler so they can do useful things for us like smartcasts. So how do we do that? Well, there's a very simple domain-specific language, or DSL, that we use when writing contracts. It currently supports two different kinds of effects that a function might have, and one of them is exactly what we need here. Let's start by writing out exactly what we want to communicate to the compiler. Looking at this isAuthenticated function, we want to tell Kotlin that, first, when this function returns true, it implies that this user is authenticated. And when this function returns false, it implies that this user is anonymous. The DSL actually reads pretty close to these two statements. As you can see, in each case, it's pretty close to the corresponding statement above. In the modeling for contracts, a contract is made up of one or more effects. This function has two possible effects. It either returns true or it returns false. And the parts on the right-hand side are called conditions. Now don't confuse this with a conditional, like if or when. Those things test Boolean expressions, whereas in this case, we're affirming that this condition is true. So in other words, we're making a promise to the compiler that says that when this effect happens, then this condition is definitely unquestionably true. So how do we add this contract to our function? To start with, let's add a line at the top of this function here. We'll start typing the word contract. Open a brace. We'll come back here and add an import for it. Okay, cool. Now, contracts have actually been available to us since Kotlin 1.3, but they're still considered experimental, so you have to explicitly opt into them. Sometime after Kotlin 2.0 comes out, it sounds like contracts are likely to stabilize. The behavior of this kind of contract is unlikely to change, but it's very possible that the way you express them could change. So all that to say, the syntax that I'm about to write here might change, but the concepts are likely stable at this point. In any case, let's go ahead and opt into the experimental status here. Just going to hit Alt-Enter and choose opt-in for this function. Great. Now let's plop our lines of DSL inside this block. Keep in mind that this lambda has an implicit receiver, and so that means we have to use the label on this here and here. Otherwise, this would refer to the contract builder instance, and you'll get this error. So let's put that back. And with that, let's build the project and come back to our on-screen loaded function and watch the magic happen. Nice, we got a smartcast here, which we can see if we put our cursor over user on this side. And we also have a smartcast on this side. So by adding just a few lines to our isAuthenticated function, we were able to get smartcasts out of it on both sides of the conditional, both the if and else cases. Now, if you're like Mr. Grumpy or Calcitrant Man, you might be saying, Dave, why I gots to do this contractization business if I can use whens instead? There are trade-offs to everything, of course, and you should always engage your noggin when you're writing code. Always think about the decisions you're making. In this case, what differences do we see between these approaches? Well, the when is very explicit. If you were to have lots of these throughout the codebase, you'd need to explicitly reference these two types everywhere. And that might be what you want. It's certainly very clear. On the other hand, the contract approach tucks away those types into the contract of this function so that they aren't explicitly referenced at any of the call sites. So in some cases, maybe you want it to be explicit, and in other cases, maybe it's just more noise. Ultimately, it's up to you and your team to make smart decisions that you're going to be happy with. Now, before we wrap up, there are some limitations with the returns effect. Mainly, you can only check for a true, false, null, or non-null value, or just leave it empty here to make sure that the function doesn't throw an exception. And the conditions can only affirm that a variable is a particular type, or whether or not it's null. And you can also combine these using Boolean operators. Now, this returns effect is only one of two currently supported effects, and there are more ideas that the Kotlin team has been trying out. But we've covered a lot of ground already, so we'll have to save those for another video. In the meantime, I'd love to hear about what uses you've come up with for contracts. Let me know in the comments below. See you next time.